Students, today we are going to see about the magnetic lines of force as a TT class. Okay, TT based class, that is activity based class. How to draw, how to visualize the magnetic lines of force around the magnetic bar magnet. So you can already know that about the our Earth planet as a act as a magnet. Every core, inside the planet we have a core, that is a ferrous core that produces the magnetic field that will be as a shield, working as a shield for our planet, protecting from various dangerous cosmic radiation from the solar. So that's why we have to know visualize the magnetic lines of force for a bar magnet. So we can visualize, we can empathize what is it has a more number of uses. Okay, it has a more number of uses in a daily life. In magnetic material we have used in a lot of applications. Now we have to know what is a magnetic lines of force as a visualization. So now then we have to defining the magnetic lines of force, particularly it belongs to the particular bar magnet. Then we have to draw and how to calculate the magnetic field intensity near the poles or wherever the place. Then we have to go for the calculations for further various applications. Now we have to today's class we have to draw how to draw and visualize the magnetic lines of force around the bar magnet. So we have a bar magnet and magnetic compass. So we have placed the magnetic compass. First we have to fix the magnetic compass in this area. You can see that this is the indicated highlight mark note as a end there. And what is that? North pole of this bar magnet. So this is south pole. So you can match this. You can mark the bar magnet in a paper, and then we have to fix it. You cannot remove the bar magnet around it. Next you have to take the what is that magnetic compass. It has an arrow indication that is defined by the what is that north pole and south pole. So arrow indicate headed and tailed. So you can place the bar magnetic compass near the bar magnet poles. Okay, you can see that it has arrow indicate this point. You can mark here. Okay, any one of the bar magnet you can place here, and do not fix. When you cannot move the bar magnet once you can fix it. Okay, you cannot move it. Then you can place the magnetic compass near the poles. Then you can mark the indication where the arrow will be indicated as a tail or head. Then you can mark it. Then you have to move the bar magnet into the vice versa. You can replace the bar magnet, moves the head end into tail end. Make it mark. Again you can make it the tail end. Another end and head end. You can make it easily. Similarly, you can move, remove, and mark where the magnetic compass or head are indicating. Then you have to highlight. You can mark it. Okay, you can see that the indication gets the arrow get deflected. Okay, you can see that you can get deflected. It will deflecting around the areas. You can see that it will deflect. The arrow will continuously deflected and moving towards the north end to south end, south pole end. Okay, so you can see that. Okay, you can replace and move and find the deflection area as a dot point, and you can replace it and again replace it. It reaches north pole to south pole. So it is moving from just you have to connect the dots from the north pole, and connecting every dots point into the north poles. Okay, connecting the dots where you marked as a indicated by the magnetic compass. So you can collect this. So this is the one side, the left hand side of the bar magnet. You have a magnetic lines of force. So similarly you can draw the every lines. Similarly you can draw here. So here, so it is as the bar magnet having the three-dimensionally. It will be cover all over the area of three-dimensionally. It has a magnetic lines of force. Once where it is you are drawn means the poles have a high intensity of magnetic lines of force. The pole strength of magnetic field strength or the pole strength will be very high, whereas compared to the other area. Just as a practice, you have to draw one setting. Then only you can visualize or realize the magnetic lines of force. Okay, you can do it work. Okay, you can you both take this bar magnet and you make it as a bar magnet and make a draw the visualization of the magnets. Okay, you can just you have to fix. Just you have to fix and draw the bar magnet. Okay, and you cannot move the bar magnet. Okay, you will move the bar magnet just, and you have to place the bar magnet nearly. Okay. Okay, just you have to place it. Yes. So it has near to end, that end. Okay, you can mark. Then move the mark magnet, and you have to fill it. Okay, similarly, get deflected. Yes, it is deflected. If you have a deflection, yes, you can identify the deflection. Yes, so you can place it. Yes. Okay, so this is the drawing of visualization the bar magnet through the bar magnet magnetic compass. This is a two-dimensional one. The paper has a two-dimensional one, so only you can draw the one side of the plane. So there's a three-dimension means that's is the direction. So above the bar magnet paper also having the magnetic lines of force. Okay, so it has three-dimensionally covered the bar magnet. So whatever the field, whatever the material placed on the bar magnet, three-dimensionally it experience the magnetic lines of force. Okay, you can draw this. Yes, you can connect the dots. Okay, similarly you can connect the dots. Okay, so similarly it has number of lines dotted around the bar magnets. You can continuously see them. Okay, okay. Similarly, the magnetic lines of force like this. Okay, very good. So this is the only two-dimensional one. So at the poles we have a lot of. Suppose you have a place of material on the north pole, it experiences the more number of lines and the magnetic lines penetrated through the magnetic compass in this north pole and south pole. Okay, that's a field strength of the material will be placed on the material will be more on placed on the north pole. So that is magnetization intensity will be higher at pole strength. Okay, so in this class we have stop here for this only drawing of magnetic compass. Next we have to how to use the magnetic diffraction or another application as a practice class we have used for various applications. The next class we will see the next another case study or activity based learning devices. Thank you. Thank you.